All right, let's look at some consecutive numbers. So these can be a little tricky. We'll go through a bunch of different examples here. We start off with this one, we see 9, 16, 25. So what we want to be able to see here is that these are perfect squares, which means 3 squared equals 9, 4 squared is 16, 5 squared is 25. What's the next number going to be? 6 squared, which is 36, 7 squared, 49, and so on. That's the first one. So we look at this one. What we're looking at 5, 10, 20, 40. What we'd like to be able to see is that we're multiplying by 2 every single time. So 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40. What is going to be next? 40 times 2 equals 80. After that, 80 times 2, 160, so on. So that's the pattern we're seeing on that one. Looking at the third one, we see 3, 6, 9, 15, 24. So what could we have here? We're looking at this, what we'd like to be able to see is that we're adding these numbers together. 3 plus 6 equals 9, right? 9 plus 6 equals 15. 15 plus 9, 24. As we add the next two together, 24 and 15, 39. If we were to keep going, 39 and 24, we would get 63, and so on. It keeps going on like that. I got 2 more to go here. Looking at this one, 3, 5, 15, 75. So here, what we're looking at is actually we're multiplying these numbers together. Right? So we have the 3 times 5 equals 15. Right? 15 times 5, the previous one, equals 75. Right? And then we're going to have 75 times 15, which would come to 1125. So that's how we would do that one. Also one that you'd see commonly. The last one, probably the trickiest of these, 1, 2, 6, 24. What are we looking at? In this case, we're multiplying by 1 more every single time, right? So 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24. What will be next? 24 times 5 equals 120.